Alex Baina here, and welcome to Chalk Talk, and today's episode will be about redshift and blueshift. Waves emitted by a traveling source towards an observer prompts a higher frequency. Away from an observer will also prompt a lower frequency. We experience this scenario by a passing of an ambulance. A change of frequency signifies a moving source of wave. When we speak of wave, that is either the sound wave or light wave. In the context of astronomy, we will consider light wave. This principle is called the Doppler Effect. A shorter wavelength of light produces higher frequency. This is called a blueshift. A star A-171 has the greatest blueshift. A star wavelength that is moving towards the Earth of velocity between 1000 km per second to 5000 km per second is shifted to blue wavelength of the spectrum. Longer wavelength produces lower frequency. This is called redshift. Star I-450 has the greatest redshift. This is a star wavelength that is moving away from Earth that is shifted to red wavelength of the spectrum. Knowing the velocity of the moving source of light can be converted to the frequency to solve for the wavelength that is calculated by the equation known as the Cosmological Red Shift equation. Here we have V is equal to C times delta lambda over lambda subscript O. Delta lambda is the wavelength shift. Lambda subscript O is the wavelength of the source that is not moving or the observer. V is equal to the velocity of source of line of sight, while C is the speed of light. Almost all galaxies are observed to have redshifts. The universe is expanding. This is usually called the cosmological red shift. If the universe is expanding, therefore, we are expected to see a lot of red shifts. But are there blue shifts? 100 known galaxies in our own local group, including Andromeda Galaxy M31, are large enough and sufficiently towards us, resulting in a blue shift.